you can sign in. And if you sign into Agouti, you have this page which is important. There is a manual, because we quite often have questions and people don't know where it is. So I will go back once over there. So there's the name, and just besides of it, it's the manual with explanation on a lot of things which I will be talking about, and a lot of things we get questions about, like how do we work, who can do what are the roles of the different users, what about AI, is there a dashboard, frequently asked questions, whatever you can think of, we try to answer it. If not, please send a mail to Agouti, and we will try to fill in the gaps. So getting back, if you click on projects, you will see that you have all your projects. For most of you, there will be one or two, maybe an EOW project and two others local projects. I have quite a bunch of projects over here, but it's not that important. So you can select a project or by simply clicking on it. The other way of working on selecting projects is saying, I'm looking at projects belonging to a certain organization, which is for me INBO. So then I will see only the INBO related or the ones we started up. And another way of selecting is by simply typing the name of the project or something which is resembling the name of the project. And then you can select the project. At the side, you will see all the different functions of Agouti. One of the important elements of Agouti is that you're able to manage your users. It's with this one, the users I see is still switched back to Dutch. So I will go back to English over here. Oh, now yeah. So I don't know why. So one of them is this with the small man. It's the users. This is a project with a lot of users, which is not that important. What is important is that if you're managing the project yourself, then you are the principal investigator or the project coordinator, which allows you to invite other people to join into the project. Within Agouti, all project is like a kind of a closed box, allowing you to manage who has access to the data, who has access to be a volunteer, which means who can upload pictures, which can annotate pictures. Some other people, they will maybe be only, see this way. You can change the role, and it can be project owner, it can be a taxonomic expert, someone who knows a lot about martyrs and who you're always going to ask to annotate the martyrs, someone who is only handling photos, so looking at pictures and annotating pictures, maybe someone who simply can view but cannot do anything at all. And you can very easily change this role by simply clicking it and or agreeing or saying you don't want. To invite someone, you click the link. You will say that he copied the link, you sent the link to someone, and the person then can demand access to the project. Let's see if no, Tancredi is not yet in this project, so I will very quickly send to Tancredi the invitation for the project. So now I will receive, pretty soon, I will receive a notice in the users saying that Tancredi asks permission to get into this specific project. By allowing Tancredi in this project, I only allow him in this project and not in many other projects. So that's how to manage the users. It's very important. It's very it's one of the key things of Agouti, because it allows us roles and permissions. It allows us to see for all the different people what they can do, and it allows us to avoid the problems of people do wrong things. Just to be sure, do you see the manual now? if I change content on the screen, or you're still looking at Agouti? Like ready?
Yes, we do see the manual. Yeah.
Okay, perfect. So that about the users. Now, if I want to, if I start a project, a new project, I have users. One of the things I quite often have, but not always, are the locations where my cameras will be. So if I zoom in on one of the spots, tree. Now I zoomed in too much. Zoom out again a little bit. So like down here, I have 6 locations which are annotated, which I can use afterwards for annotations. And like you see, if you change the level of zooming, it splits it up till a certain level until you can see those are very close to each other. For each of these locations, you have the name. The 2 ways of adding a location. One is the manual one, saying this is called a demo location. I can select a certain feature, like it's a water source or it's a road, or I can say it's simply nothing, and I leave it open. I can add the location over here, or I can simply zoom in, looking for a place close by, and say, well, in this forest, it's on the end of this road. And then I have the location added. So it's called a demo 2025. Add location. So that's one way of adding locations. There's another way of adding locations, which is uploading a CSV, which has all the locations there, which is quite often the way we use it. Definitely if you work with long lists. There is an example of the CSV, what it should look like. I don't know if it's going to open. Is it opening? So this CSV should always have the same constellation or the same way of creating it. Let's see there. Where's So this should always have the name of the title should always be name, lat, and long, and LNG, long, the name of the place, and then the locations. This allows you to have a long list of places which you will have cameras on, and add all the locations. So that's how I bring in my locations. In case I would have to do it later on, you can see that you can simply still add them. Then the next very important stuff for everybody is, how do I get my pictures into Agouti? Which you do by adding a photo sequence. I have to start by adding where the pictures were taken. So I can select one of the existing ones. But if it's a new place and I did not yet select it, I can also, at exactly the same way as I did before, add an extra point in Agouti at that moment. So I have my point. Now I come to one of the things where we get a lot of questions about. It's the way we say in which time zone pictures are. So I selected UTC +1, which is the Central European time. So it's winter time. There is also a Central European summertime. It should be very close, but anyhow. So Central European time, winter time. And that by saying this, it's UTC +1. Now Agouti knows that all my pictures and the time annotated or the time stamp on the picture will be UTC +1, which means the Central European winter time is the universal time +1 hour. If I will, like it's written, the photo timestamp will be 1405. the UTC timestamp will be 13 hours 05. If I make an export or whatever I do, time that is joined to this picture will be the UTC time. There will be an annotation that it's +1 or Z. So Agouti will know, the export will know, R will know that in reality, the picture, the time on the picture was 14 hours 05, but the time which is joining the picture will be 13 hours 05. It's very important because we got a lot of questions about it. It's also important because if you work with activity rhythms, if you work, the computers almost always assume that the time is UTC. So don't start then handling around with the time because the computer assumes it's UTC. That's also the reason why we really promote using read CamTramDB to import the images, because if you start to fuzzle around with read CSV or whatever other R code or without these specific functions that know in which time zone time is, you quite often get into a problem. So how do I get my images over there? I select images. It became really very simple. You go to the place where the images are. Let's see, we were in the field last week. So he's showing you all the images which are somewhere on a disk. I will select some images. So I want to have those images. And now I hope that the internet is strong enough. It's working, as you can see below, but my internet is really slow today. I hope it will work. Maybe not. Still turning. So it's to make it clear, this time it's not Agouti which is slow, but it's my internet which is slow. Probably also because we're in a video conference, many people. Simply click it out for a moment. So we'll go back to this one in the meantime. Something else we get questions about is if I'm uploading, so I selected a point. I could put in the right time. You don't have to fill in the start and end date. Computer will use the start and end date of the first image in the sequence to fill it in itself. So don't, and it can take some time. Then you have to check for some labels. I will get back later on where you define the labels, but the labels allow you to give to each deployment specific labels. It can be a feature, it can be an array like having all labels with feeding and labels without feeding. It can be a habitat type. It's a feature, it's a label which allows you to make very easy selections afterwards. There can be a camera label, but we never use the detection distance of the camera. It's not, Agouti is not using it for anything, but it can be important if you use different types of cameras with different sensibility. The height of the camera, which is important because it's exported afterwards. Also, if of course you work with a standardized height, it's not that important because it can be part of the project settings, but we assume or we ask you to fill it in anyhow. If the camera is looking north, south, east, north, out, west, if it's flat or if it's tilt, if we're using any kind of bait, who placed the cameras, and some notice like camera broke down after a while. And I'm going to switch to the PowerPoint because the computer is too slow. Do you see at the moment the PowerPoint now?
Yep.
Okay. Now we a lot of the images. Let's get back and put them all on again. So this we just had, putting the time right, sampling points, getting all the images in. So then we get to annotating. There's a possibility to annotate by AI, or there's a possibility to annotate manually. This is again some stuff of the sampling point, which we still can change. Like I just said, it's part of the project settings. And if we go to annotate manually, if it's still running there. Now I'm back in the screen normally. But those are now all my photo sequences. Like you can see, some say we still need files. Some say we still can annotate. So if we're going to annotate manually, I click on annotation. One of the strong points of Agouti, for those who have not been using Agouti, is that Agouti itself puts all the images together that belong to one sequence. So I will have a look to the next sequence, hoping that I find some. It's 10 again. 10. Okay, there we are. So, which means Agouti at the moment, if I look at the project settings of this project and of most projects, the time sequences are subdivided based on an interval of 120 seconds or 2 minutes. What does it mean? It means that if I get back to my annotations, and we get back to this one, it means that the camera started to work, which I can see over here because it's written M of motion, first of 10. Computer takes 10 images on a row, the camera. So the camera starts working, and Agouti puts all the images together of such a kind of a photo burst. So there is the first photo burst. There is the animal. Let's try to get in some more light. So there is a rodeo buck who walks through the images. We're at image 5. 6 of the motion, 7 of the motion, 8 of the motion, 9, 10. At that moment, it was 2 o'clock in the night, 18 minutes and 51. Immediately afterwards, a second, this is a demo, so it's a second image is appearing, which is at exactly the same, less than 2 minutes away. Let's go back. To 1850, to 1851. This is image 10 on 10. And on 280-2064, there is a new trigger of a new animal. Could be the same, could be a different one, but it's less than 2 minutes away from the last picture of the previous one. So by consequence, it's subdividing this. It's putting these two images together. So now we have a sequence. If we go through the sequence, we have seen 2 rodeo bucks, which allows us to say, I have a new observation. It's an animal. That's the languages, it's in Dutch there, so it's a ree. How many did I see? I see 2 of them. They were adults and they were males. I can decide to say they were foraging, running, and I can save this Imagine, and this is a very important one, imagine that in the same sequence, I would have a roe deer fawn. I will call it a new observation. It's in the same sequence, but I have a new observation, which is again a roe deer, but its age is juvenile. I don't know if it's a male or a female, so it's, and then I save it, which means that within the same sequence, I have two observations, one of a male, one of two males, and one of one fawn. This way of working with two observations allows us to select afterwards all the observations of fawns, rather than all the observations of only roe deer and then having to select them. This is also important if you start to use the data afterwards, because it's one event. It's an event. We have seen roe deer at the 8 of 22 in the 9th. So it's one event, but it's two observations. It's more than semantics. Let's put it that way. If I get to I will go back because here is a new observation of a roe deer. If I have an observation, so now I selected animals. I will try once again to change the language of this project because I don't like it. Where is the language? No, this is total. If I have a sequence, now it's 10 images. I have the option to say, I've seen an animal and I would like to annotate the animals. It's blank. I don't see anything at all. It was a pickup setup. For those people who have been using a lot of camera trapping, those pickup setups, they're this kind of sequences where all you see the hands of the people putting the camera, or you see cameras moving in all directions because people are still connecting the camera to the tree, seeing the sky, seeing the bottom, seeing faces of people looking in. So those are the pickup setups which you use to, let's get back to the sequence. Yeah, so it's a pickup setup. It's a vehicle. Why do we annotate vehicles separately? Because in the old days, we called them humans, but a car is not a human being. And for AI, then you get something very weird. So we have vehicles. We have the calibration of the images, which I will discuss about very soon, or it's unknown. Please be sure to use unknown only if it's an image of which you say nobody will be able to tell what's on the image. So this kind of pictures or sequences where you have an animal which is coming at such a speed and so close to the camera, nobody can ever do it. Don't use the unknown for a pine martyr or a stone martyr of which you don't know which of both categories it is. It is unknown to you, but it's not an unknown image sequence. If you don't annotate it, maybe one of the colleagues who is also joining in the project will be able to annotate it and say it's a pine or it's a stone martyr. If you say it's unknown, then the sequence will maybe not be presented again if someone selects all the non-yet qualified classified sequences. So take care of this. So that's the way we annotate. If I go to look at the photo sequences, those are all the deployments or all the sequences which I can annotate, which I can put the AI, there's annotation by AI, or where I can simply, given that I'm the main user, I can also, if I go to edit, we can still change this and I can delete this deployment, this photo, this sequence, all observations of it. It's only some of the top level roles that are able to do this. Otherwise, we would quite often have problems with people deleting images. I'm very quickly going to back. See, there you see. So in the users, now I see that Tancredi asked permission to this project. So I get this demands of people who would like to join. I have Tancredi. Tancredi used the link I sent to him, and I will decide if I put on the red button, I refuse Tancredi, so he's not getting access. If I'm putting on the other one, he's asking if I'm sure that I would like to have Tancredi on the project, and then Tancredi gets onto the project. So if I look now at Tancredi, there he is. And by this pencil over here, if you add a new person, he automatically becomes a volunteer, but I can decide that Tancredi, I would like, the point is that volunteers, some things volunteers cannot do. They cannot add a new species, or they cannot add. So I know Tancredi, and I don't want to get bugged each time when he wants to add a specific bird species. So I simply make him project owner, which allows him to do a lot of tasks himself. But please, please take care of who you give which role, because you don't want to lose control on your project by giving too many permissions to too many people. So we have the photo sequences, the deployments, we have the observations, which we annotated. Using the observations button, we can select within the observations. I selected now all the Gabriolis, so all the roe deer, which allows me to have a very quick look to see, okay, there is one, for example, it's a roe deer. It was done by the AI, so it was annotated by the AI. I'm not sure about the AI, so I will have a quick look. And I directly come into this photo sequence, and let's have a look. Why is he saying that there's a roe deer on these images? I don't see any roe deers. So it looks like the AI did something I don't want him to do. Oh, there he is. So the AI was right there on the background. I don't know if you can see it at home. There is a roe deer. So the AI found the roe deer. So it's okay. And I can simply click it out and know that the AI has done wrong. For those questioning the AI, so for me, this is this kind of images that I'm really surprised of, that the AI is able to recognize a roe deer that somewhere in the background is running between the trees. See if I can get the animal back. There it is. One back. Those two buttons on the top, they allow you to get more contrast in the image, more or less light. With more light, it becomes more evident to see there. With this button, this download button allows you to click and download an image. It's a button we created because many people asked us to have this button, allowing you to see a good image and immediately doing a download to the computer. Using this one, it puts it back on the right in the middle, because using my mouse, I can zoom into the image. Now I see very well it's a roe deer. I can zoom in, I can move, and by using this, it's putting it back to the original colors. By clicking these ones, I can create the full image. And if I look on the info, I get all the EXIF information, which is connected to a picture, and which stays with the picture. So by now, I know how I can allow people to work on my project. I know how to add new locations, how to put in new pictures, how to look at the observations that I'm interested in. I can select on the species, but I can also select on, are they validated or not? Maybe I have someone annotate, but imagine Imken is one of my PhD students, which some of you maybe met in Norway. But imagine that I know that Imke is really bad in annotating foxes or annotating roe deer. I can select to see all the images that were annotated by Imke. So this allows me to make selections on. I can also decide that I only would like to see those images that were taken on a certain location, being the 117. So this new or this observation dashboard allows you to go very quick through observations, select for images done by someone. Maybe I would like to select for all the images done by the AI. So I say West. No. Okay, let's go back to. Oh yeah, that's because it's 117. There's no images 117 done there. I see I have Western Europe version 4, version 2, and those are all AI images. And as you can see, some of those AI images, they were made by AI, but they were then changed by me or by someone else. So this allows you also to see which images were or were not yet changed by someone else. The only thing which I have to say, which is a watch out, is the timestamp that at the moment is given over here is not the right one. Something with the settings of your browser will interfere with this timestamp. So don't look at the timestamp. I mean, it's not completely wrong, but let's have a look. If I take one in the summer, like this one, it thinks the timestamp is 194, and so that will be in the night. If I look at my image, it was 2394, so there is a 2 hours difference. That's simply because my browser knows that in summertime, the difference between UTC and the real time is 2 hours. So it's not wintertime, it's summertime. But we got a lot of questions about it, but please don't panic. If you export this image, it will show you the right time. So don't worry. That's a browser issue. So I have locations, deployments, observations. I have a species list, which is I have in each project and which you can change in each project. I have a camera list. We don't use it anymore, but it or computer knows a lot, can select a lot of the cameras itself. I have the people using it. I have my project settings. What are the project settings? They are the name of the project, a location. It's a central location of the project, which allows us, if we make images, if we make pictures or outputs on where are we having at the moment projects is. I have the UTC, I just explained it before. So the best thing to do is to put in the project settings, the UTC coordinates, if it's +1, and then it's using this for the whole project. Within a certain deployment, like I showed before, you can change it. Maybe you have a computer that a camera trap that was wrong, so then you can change it. But in reality, this is the best to use. Simply put it over there. There is a description. Until now, for many of us, this description was simply how I have to fill it in. Don't bother too much. But please start to use the description to write in English a good description of the project. It's part of EOW. It's done this way because this description, which is over there, will be used afterwards in GBIF to describe your data set. There's some other stuff to click. Oh yeah, I can add a picture, which is of course nice because if I go to the list of projects, it's the picture that appears over there. Again, it can look like is this very important. It's not that important, but once you start to manage many projects like I am, the pictures are a lot easier to find your project than simply titles, which all of this different annotating, this different Agouti image. Let's get back to my project. Other locations that some people cannot see, this can be clicked, which means that this way, if it's appointed, people only see, the volunteers only see those sequences they have themselves put in the project, which allows you to have many people joining in a project, not seeing the sequences or the pictures or deployments are uploaded by someone else. I can use the deployments to appoint to someone, which means that if I have many people annotating, I can decide which of the deployments are attributed to Tancredi and which are attributed to Joachim to annotate. And I can work with Nextcloud, which is out of scope for this meeting, but which allows volunteers that can have no access to Agouti to put the images somewhere in the sky so I can very easily find them. Who is responsible for the project? Who is the contact person? What's the institute? What's the setup on the field? Are we using, but I will use Agouti, this one again, because it's English over there. This is all we have seen. No. Where is Agouti? There. Am I using bait? Am I not using bait? Am I using meat as a bait? Do I have an acoustical bait? Do I use smell like wild boar? Do I use something else, or do I use no bait at all? This is a very important one also. So like I explained down here, the subdividing of sequences is based on how many seconds. This is, you cannot change it. Until now, it's clicked, it's fixed on 100, it's fixed on 120 seconds, or which 120 seconds or 2 minutes. We made this one, or we used this one, and we made it impossible to change. So we're sure that within all the EOW projects, we have the same time between two photo sequences to become two observations. This one, the delay, it is after one burst of pictures, how much time is there before the next burst starts? What's the setup? Is it an experimental one? Is it a systematic one? Is it a purely random one? Is it a stratified random one? Is it purely opportunistic? It's also very important within those people joining in big picture know how much the impact can be of a sampling design on what we can conclude. And over here, I can select the AI. Agouti is using, as I would call it, external AI. So if you select an AI, we can, or if you have an AI, we can put it into Agouti. So like you can see, you can select Deep Fawn from the French people developing, or you can select one. We are at Europe version 6 because the AI is all the time trained, which is then the latest version of the Agouti AI itself. So, and the final thing, which only PIs can do, so project responsibles, is create an export. How do you create an export in Agouti? Very easy. You click the button, create export. You will see that then this starts to turn, and it takes a lot of time. Everything is okay. Just leave it turning. Maybe if you get back in 20 minutes, you have to refresh the page. And once you've refreshed the page, you will see that there is a download button or a remove button. If you remove it, then this download, this export will be removed. If you leave it, it will be there. I will not go into the details of what an export looks like and how to work with the export. That we deal in another session. My suggestion would be, Tancredi, that before I go to the annotation and the calibration for the random encounter model, I leave some minutes so people can maybe ask a question on Agouti specific, or okay. So if there are specific questions on Agouti, then please, I think it's the moment now. I hear someone, but really in the back. Valérie has a question. Salut, Valérie.
Salut. Yes, I have a question. I'm just wondering if there is any possibility to correct data within Agouti, for instance, date or that sort of things? Is it possible to correct files within Agouti, or we have to do it in the code afterward?
Okay, so if the startup and setup date are not correct, you can change it. I simply don't see why it's not changing the language, but that's my problem now. So I will go back into Agouti. Melvin projects. So the deployment, if I edit the deployment, so the starting date and the end date I can change. Yeah. So that's one afterwards.
Afterward, after annotation and all that.
After uploading, you can change it.
Okay.
If it's an hour which is wrong, like it's 1 hour wrong, or it's in summertime and it should be in wintertime, then the easiest thing is to change for this deployment, this specific deployment, so not a project, but this specific deployment, so there is the time setting is done on the level of the project over there. But if I discover that I have a sequence, photo sequence, let's say it's the I all of a sudden discover that this photo sequence on P11, for some reason, and the reason is called my student, he put it in summertime and not in wintertime. Easiest things to change this. It was summertime, so it's there. Click. No, I only want this one. He's selecting too much, but there you have it's UTC +2. So if I'm telling the computer, sorry, but this camera trap was in summertime, I can use this specific deployment on this specific period and say it was summertime. So that's the way he will automatically, in the export, the UTC will be right, because he will correct and say if it was summertime, it was a 2-hour difference. So if it's a whole sequence or whole deployment, which is 1 hour in the wrong way, whatever way it was wrong, you can use this to correct it. What's impossible to correct as a user at the moment is the camera trap was in the wrong year. So this can be changed in the deployment start and end, but not for all the pictures. In that case, there is only one solution, but I cannot advertise it too much, but it's send Jorik an image, send Jorik a mail and ask him to change it. He can do it by the back side of the computer, by the back door of Agouti. He can go into Agouti and change it in the database. But that's only for the rare case where it was a wrong year and you should change the year. I would not advise to solve it in the code, because if you're going to upload the images afterwards to GBIF, the data set, then it's again the wrong settings. Or you have to correct it in the code before the export, between importing it once and re-exporting it afterwards, which is not the way we would like to work. Let's put it that way.
Yes. Can you repeat the end?
The end is a wrong hour of a specific deployment. You can change by
changing over
giving the correct hour for this deployment by setting that it was 1 hour wrong. Correct wrong year, you have to send an email to Jorik or to Agouti, to the Agouti mailbox, saying this deployment in this project has the wrong year. Please, could you correct this? It's also the reason why, if you look at the users, you will find, I cannot change the rule, but you will quite often find some people who have admin. You never allowed those admins to your project, but once you create a project, there's certain admins which automatically have access to your project exactly to be able to get to the database. Is this an answer, Valerie?
Yes, thank you very much.
There you go. Nuno.
Hi, everybody. Just a quick question. Is it already possible to separate the sequences on pictures when merging was done erroneously? And I have a second question was about this situation of the year, but thank you already for your answer.
I don't think at the moment we already can split them in Agouti itself, no. But when are they added erroneously? Because there's less than 2 minutes between, or how is this happening?
For example, that by mistake one picture was merged to a previous sequences and it doesn't belong there.
And it happens often?
No. It is just one situation we were trying to sort out, but there is no information on it. Do we have to contact technical to do it?
Yeah,
or we have
I would also contact the technicals because it's not a standard issue which is there at the moment yet. And
okay.
Sorry.
No worries. Thank you very much.
Any other questions? If not, I will change the PowerPoint.
One in the chat.
Yeah, sorry, I cannot see the chat. Wait, let's put on the chat. Yeah, is everything working with videos? Very good question. Not yet. The biggest problems with videos at the moment is that, as I showed, let's see, let's get back to an image. So if I'm clicking on this is the EXIF file of a picture, and so the EXIF file is telling me that there was a Reconnect, that there was a hyperfile 2 covered, in which resolution, when was it created, which is very important, like we just explained. And so videos don't have this kind of an EXIF file. And even worse, if you move videos and you copy videos, the time of creation is changed because it's like a file. And so we still have a problem in Agouti on how to get the exact date and time out of a video automatically. So you can upload videos, you can annotate videos, but the timestamp is still something which you have to do manually. And we're working on it at the moment. We're looking at the colleagues of Valerie already create something to get the date out of it. So we're really looking into it. Definitely also because we see that there's a behavioral studies, but also for maybe the tracking and the random encounter model, we really would like to have it. So we're working on it. It is worth to mention. Yeah, thanks. If you upload the images, like we said before, like I showed, if the image have exactly the same name, he will consider this to be a copy. So if what happens quite often, if you, I don't know if I have an example, but if you have a lot of pictures on the same deployment, the computer will create a second folder on the camera. In Reconnect, it's called then Rec 110 and then Rec 101, so 101. But in the 101, it will restart again with image 1, image 2, image 3. So if you would upload them to the same location, he would think it's the same image and he would only keep one. So before uploading, you have to change it. Although, and I should check it, Jorik told me that at the moment, it's no longer necessary to do it manually, that he would know it himself. But I would have to check it if it really works now. And yes, it could be that it depends on the camera trap also. But I will check this and maybe then we can pass by Tancredi of the EOW of the list server. I will tell the answer on this question. That will be a good one. So after the break, Marcus will give some more explanation on how this works. I will just show you how we do it in Agouti. So the point is that for the EOW, we work with the random encounter model, which Stefania was referring to before. Also, the random encounter model is one of the few methods available at the moment to have an estimation of real densities of animals. So not simply be able to track trends based on relative densities, but have something which is really a density. So resulting in a certain number of animals on a square kilometer. The whole idea about it, it's written by Marcus in several papers, Marcus Rowcliffe. I use this picture quite often. So the idea is we have animals running around in the area, and we place cameras randomly in this area, randomly compared to the animals. And to allow to end up with a density, we need the number of observations, so events where we see animals, divided by the time. That's simply to have a relative correction for the time of the observation. And we need to know, we assume the animals to move through the area as being a kind of gas particles. And so to estimate the density, we have to know how quickly they move in this area in the time they're moving. So how much time are they moving during the day? But we also need to know the effective, a little bit like in distance sampling, the effective observation area of each camera, which is not the same as the detection distance of a camera, because depending on the local conditions, a camera that can look for 20 meters, maybe in reality only can look 5 meters because of the vegetation. So we need to know how far of radius, how far is this camera trap able to look, and what's the angle, T. So there we need a distance, the angle, or how wide. And again, if you buy a camera trap, it will tell you that it has an observation angle of 45 degrees, but in reality, we have to see it for each deployment. And then we need to speed the velocity of the animals. How do we do this in the field? We need the activity level, which everybody can calculate based on the age, the time of the picture. We need a speed, for which we need to know how is the part of the animals through our images and time, and we need the detection area. To do this, we are going to create a 3D view of our 2D images. We need to calibrate the camera model, which is something you don't have to do as being a user. And then we go into the field. And in front of the camera, we're going to move around with a stick. This is me with a stick. And on the stick, there are markings saying this is this is 20 centimeters, this is 40, 2 bars is 40, 3 bars, 60, 4 bars, 80, 5 bars is 1 meter. It is important that the stick is touching the floor, and it's important that the stick is straight up. And at the start of the deployment, or somewhere in the deployment, for each specific location where you would like to do this, we're going to walk around with the stick and stand on several places. If we get back, at the moment, it's still manually, so we have to look for collaborators, students, a PhD student, or someone who is going to look at those images. And in Agouti, you will not select it's an animal, it's not a pickup, it's a blank. It is deployment calibration he's selecting. And within this calibration, you can click with your mouse on this first point. You get the star there. And then there you write bottom of the stick, and I say it's 20 centimeters height. For the same stick, the same image, I will click on the top, or whatever I can see, and I will say it's 1 meter height. Some important issues is we have several distances over here. This is because due to the vegetation, we are not sure which ones you will be able to see. So that's why we need to say, okay, maybe I can only see, due to a lot of bush in the front, I can only see 60 to 1 meter. Then I select, maybe for some reason, I can only see 20 to 60. So this way of working allows us to click on the stick for those distances or those markers we can see. What else is important? We always click on the top. So if you bring in the markers on your stick, please be sure that 1 meter is on the top of those 5. So I've done this for one stick. Now I move my stick, and this is a bad image because the stick is not straight. I move to a second place. I move to a third place, and I don't know if you can see it, but we use this like they use in the constructing to be sure that it's straight. So now I do this 10, 15 times until I have enough points in the image that afterwards I can make a 2D image out of this. Now we have, and it's always clicking on the ground level, and based on the fact that we calibrated this camera type and the EXIF file is telling which camera type this is, Agouti is able to say for this 2D image to make it a 3D of how far this pixel in the back, sorry, this pixel in the back, that this will be like 10 meters far away. So now this is done, and so we have a 2D image of a 3D image based on our 2D image. Now we need to follow the path of the animals in the image. We go to the observations, which we selected. We know it's a roe deer, and now we can start, there it's written, jump to position 1. Now we can start to click on where its front leg is. And so the front leg is over there. And we click where the leg, like with the, because the button was standing on, the stick was standing on the floor, we click on the position of the floor of this front leg. And in the second image, no, the second image is not there. This is the third image. So you see, this is motion 2 out of 10. This is motion 4, so with 2 images further down. And again, I click on the place where this leg hits the floor. Given the fact that I have the time stamp of each image, first image was 38:64:46, and the fourth image, or the third leg one, is 38:47. So I know the place and I know the distance, so I can calculate the velocity. It is very important to click the point where the leg is hitting the ground, and if you cannot see it exactly, or you skip that one picture, or you estimate where it will be. What you cannot do, what we did in the past, what people do in the past, is, well, I cannot see very well the leg. Let's click on the nose of the roe deer, because if I click on the nose, the computer will think that the location of the nose is where the roe deer is hitting the ground or where it's standing. Now you don't need a lot of imagination to imagine that if I look at this roe deer and I would click on the nose, and the computer would think this is the front leg or hitting the floor, then the animal is standing far more to the back than it's standing in reality. So that's the reason why you have to click on the legs. So I can follow the whole trajectory of this animal, which in the export gives me the speed in this sequence of the animal. Here I'm not able to click the animal. In the example, someone did it, but I would never click on this front leg estimation because it's really impossible to see. So simply you skip the image and you go to the next image and you say, well, there I can see it again. We have enough images quite often. It's the advantage of Agouti also that we work in these sequences, so you can walk through the sequences to get the exact speed. The place where the animal entered, that's the point of entry in our image. This will allow us to calculate the distance, the detection distance, and detection angle to calculate the detection area. This trajectory allows us to calculate the speed of the animal. We're all dreaming of the next step when this will become an automatic or AI in Agouti. So you can simply say, I would like to follow this animal, and the computer will do it. We're not yet there. So at the moment, it's a manual task to do it. Track. At the moment, our advice is if you have, like definitely with wild boar, you have several animals walking to the same sequence, just select one animal. Select one animal in one sequence, maybe the first animal, and click on starting point. Perform the whole process, I say, for this one animal. And then go to the next sequence where another group of animals, the next observation, and then reprocess the whole story. In the export, all this information, so the position of the sticks, as well as the trajectory, as well as the entrance point, it will all be exported. And using ChemFabDB, using programs Marcus Rockcliffe have been writing, it's very easy now to make the random encounter modeling once all these steps are done. But this is a very crucial one. And although we often use students to do this work, don't forget that if this work is done messy, whatever gets out of the computer as a random encounter estimate, it's messy. Maybe one more thing about the sticks before I forget it, because we had a problem also with the student. Please ask the people to do it, to be very conscious in saying, I click on the point, low point of the stick, I put in the height information. I take the second point of the stick and always use this sequence. If you have people who start clicking bottom, top, and then start to write 20 centimeters and 1 meter, it quite often goes wrong because the connection between those two clicks is important for the computer. And I think that's about it, Tancredi, regarding the how to calibrate the images for the random encounter model. I don't know if there are questions at this moment. I can see the chat, so if someone prefers to ask the questions by the chat, it's also possible. No questions?
No, I think you can probably. No, there's one.
Oh, I do the. Oh no, it's the same. So you can also do the top and the bottom. As long, I mean, I would advise to do bottom and top, because we all do. But that doesn't matter. What is important is the sequence of clicking on the image and then telling, using the site where you are, and not doing twice on the image and then the two altitudes or the two heights. Other questions? Okay.
You probably mentioned it, Jim, but perhaps I missed it. The fact that the distance is usually not there and you don't have to worry about that. In the image, you have the distance box as well, but that's not.
Yeah, no, don't. So in the image itself, so in that distance, it doesn't matter. The computer is doing the calculation, so you don't have to fill it in. No, I don't know even why it's there.
Yeah, because usually you don't. It doesn't really show.
No. I should wait. I will very quickly see if I can get into Agouti. An observation. Is something? No, I don't need this. Observation time. No, so the I don't know if you see the PowerPoint now or the Agouti.
Yeah, we do see your screen.
So you see someone walking around.
Yep.
Okay, so then you also see that that it's this is the current, how it looks like currently. The previous pictures in the slide were, so there you see that it's really simply only saying top, bottom of the stick. So there's no distance anymore over there. So just filling this. And maybe going through these weird images of collaborators doing funny thing in front of the computer, in front of the camera. Please, if you're standing, once you're standing, let's see. Well, the two things we do. I can see if I find an image, a better one of the calibration. No, that's in the dark. So this is a classical pickup setup also, where the computer is still moving. Oh, there we go. Then I will see if I can find one a little bit. So what we quite often do also, to be sure, is once your stick is standing straight up, because as you can see, you will end up with a whole bunch of images, because you're walking in front of the camera with your stick to all the different points, and so he's taking many pictures. So it is important for the guy who's annotating to know what are the pictures that I can use of the person with the stick and what are the ones he's moving. So what is important is that at the moment your stick is really hitting the ground, so it's there and it's straight up, then you give a thumbs up, or you wave with your hand, like saying this one is the one who's okay. So there I am with my hand waving, saying it's okay. So now the student afterwards knows that's the one I'm using, or I'm allowed to use. It's not, let's see, there's a lot of images. Where am I? Oh, I have to zoom out. There I am again. But many of the other pictures, this is clear that it's not straight. But arriving on it, that now I'm out of the image. There you see again, there is my hand saying, now it's okay. Because the image is just before or just after. It could be that I'm still walking. It could be that the stick is not yet on the ground. And this is, in this case, it's obvious because you can see the ground. But in other cases, it will be very difficult to see. So, but it's only top and bottom you have to click and fill in. No marks there. Okay. Don't know if there are other questions. What's the minimum of tracks? So I think at the moment, and then I'm talking about tracks in a certain, so afterwards, but Marcus will deal with this later on. But you need like 40, 50 tracks, but not in the same, not in the same deployment, but in the same EOW observation period. You will see automatically also if you have more, if you have less, then the confidence interval becomes bigger and bigger. So I would always rather look at the confidence interval, which is part of the export after calculating the random encounter model. I think that's more important than the number of animals. But having at least 40 is what we also use in distance sampling, and I think it's also one of the points we give with you. But for example, you could collect more tracks, but in more diverse situations, then this will simply end up with a bigger confidence interval. So it's not always a direct connection between the number of tracks and the reliability of your estimation. Other questions? That's it for now. Okay. Then I think we take a break now, and Marcus will take over after the break.
Sorry, Jim. I perhaps can ask you a couple of things that that I got asked quite a few times, so to make them clear. One is related to the those cases where you only get one position that could be digitized, like you only get the animal entering or getting out from the frame. Does that make sense to be digitized for the parameter to be taken for radius and angle and not for speed, or should be just discarded?
I mean, well, you definitely you never discard the image because you need the observations. So he's calculating.
Yes, sorry.
But I would not use it. I would not use it to calculate the other information. That will be there's few reasons to do so. So you need it. It's the same for the number of observations there, because this is the group size. If you have a lot of pictures with more animals, but I would not use I would not bother clicking on this one animal. I hope you have enough other sequences with animals to do it. The question we also quite often get is how many locations do I need to have? And there it's definitely clear that you need 30, 40 also locations to get a reliable estimation of the area you're working, because it's using, so for the entry point, for the distance and the angle, it's using the information of a deployment. So you need enough deployments to calculate these angles and distance. For the is summarizing the points for deployment. And you will see if you work with cameras standing in the same position, the n, so the number of information he's using is the number of locations, and not the fact that you were twice on the same locations. It doesn't matter for him. Yeah, you need, if you would like to estimate differences depending on the behavior, you will need the same number of sequences for each behavior category. And we're discussing the same point at the moment. If we would like to have densities for like fawns versus adults, you need tracks. You simply have to think about it the way, like, you need all the estimation for all the species separately, otherwise it will never work, or all the subclasses. Which animal do you annotate? I always try to have the first animal, but maybe that's a question to ask also to Marcus this afternoon. For me, I use the first one because in my mind, it's the one who's triggering the camera. So if I would like to have an idea of the field of observation, then I need the first entry point. So it will be the first animal. Okay, Tancredi, those were two questions on the chat, but back to you.
Yeah. The other one was related to those rare cases where you have unusual behaviors. Like, for example, it could be in rodeos, you have a buck chasing a female, and that sometimes like run around a single tree for minutes, and that could cause, for example, 20, 30 new observations because they are getting out and in from the frame. So are those rare cases where it could be an option not to consider a new individual each time, or
I would not use
it, or is it better to always stick to the rules, let's say?
Well, the point is that you let's see, I don't know if you see me or what you're seeing at the moment. The point is that you don't need to annotate, or you don't need to use all the animals. If you have enough, like if I'm talking about rodeo or wild boar in our study area, I have more than enough sequences and more than enough locations where I can see the animal. That if it's a deployment on a really weird situation or strange situation, like in a where it's going too steep, or where's like where there's a river, so they always jump over the water pond, or they come to drink and they stay a lot of time. I get rid of them. I mean, I consider them to be abnormal behaviors, and I'm not going to use them to do a density estimation. So if you have a bug chasing a DAW, I would not use it either.
No, sorry. I was not talking about the digitizing. I was referring to the annotation. So to the counting of the animals. So like
okay.
each time they're getting out and in, I'm counting them again, right? So is this, but this would, and I'm pretty sure that if I have a buck chasing a female, that's always the same two individuals. So this is something I got asked quite a few times. And I think it's a bit tricky because yeah, it's unusual, but to a certain extent, it might somehow inflate a bit the numbers.
Yeah, but it will be really low inflation. I mean, if you're doing other kinds of analysis, if you're using the detection table in CamSharp R to create your detections based on the export, you can change or you can enlarge the time of independence between two sequences. And what we quite often do is enlarging this one a little bit, like 2 minutes, 5 minutes, 10 minutes, and see if this has a big influence on the number of observations or the number of observations by unit of time. And you see very quickly if it has an impact or not. And the impact until now, what we have seen is really, really low. But of course, if you have a lot of exceptional cases, but also the chasing is in summer, so normally we don't use this this time of the year for the random encounter model stuff. But okay, I mean, those are the typical ones. For me, those are all those exceptions that only create a kind of a noise on the image on our analysis. So I would always try to correct for them if possible. I had a question that if we do not record at least one position per animal, is that animal taken into account when estimation? Yes. So the number of animals and the observations are used independent of the fact if the animals are tracked or not tracked. So that's based on the number of events and encounters. So that's also the reason why, but Marcus will show it later on also. If you look at the output of the random encounter estimation in R, you will see that he estimates the detection rate, the entrance distance, the speed, and the radius, and the activity level, and the number of observations, or the n, the statistical n, so not our type of observations, but the statistical number of observations used for each of those parameters quite often is different. And that's because one is based on the number of deployments, one is based on the number of animals tracked, one is based on all the observations of animals. So it's using the error on this estimation is multiplied or is prolonged or pro-used in the total calculation. Do you have some more questions, Tancredi? Your side?
Thanks. So if there's no other questions, I'd say that we could have a break and be back in 15 minutes.
Yeah,
so
I will have to jump on a train, Tancredi, so I will not be there in the second part. But I'm definitely sure that Marcus will be able to solve.
Yeah. Okay. Thank you, Jim. Thanks for everything.
Bye-bye.
Yes.
See you all soon.
So everyone be back in 15 minutes, please. Right. So we should be able to resume. So now Marcus Rockcliffe is going to explain the second part of the course, which is going to be about how to deal with the output file, the export file that is going to be resulting from the the activities that Jim just explained. So from after the annotation and the animal movements digitizing, you're going to obtain this export file, and which is then going to be analyzed in R. So whenever Marcus is ready, we can start with the second part.
Okay, good morning, everyone.
Hi, Marcus.
So, let me share my screen. Okay, so I wanted to start with a very quick refresh on the background to why we're doing everything we're doing. I'm sure many of you are already very aware of the background to random encounter modeling, but I wanted to just make sure in case some people have some doubts or questions about the underlying process, we can spend just 5 or 10 minutes going over the background theory to how it all works. Yeah, and do shout at any point if there are questions. I'm happy to stop and discuss. So the basic idea of the random encounter model is that there is a signal of animal abundance in camera trap data. So the more observations we get of an animal, in principle, the higher its density should be. However, there are lots of other things that affect that. I've just listed, not necessarily exhaustively, but a number of things which can also affect the number of records that we get. Effort is the obvious one, so that's an easy one to control for because we know how many cameras we put out and we know how long they operated for. That's recorded in Agouti and comes out in the data. So we can easily control for that by essentially taking the trap rate, the number of records per unit effort. The other thing which can affect how many records we get is the sampling strategy and how animals use space relative to where we put the cameras. As you, I'm sure, know, it's very easy to boost the number of records you get by putting the camera strategically to try and choose favored places where you know your focal animal is likely to go, be that trails or salt licks or whatever that strategy might be. Which is why for a random encounter model and for indeed any unmarked density estimation method, we can't use those targeted placements. We have to use some sort of randomized placement. And then we get to the more REM specific things that can affect our trap rate. So we know that if animals are not very active, or at least not active on the ground where cameras can pick them up, we're going to get fewer observations. So if all else being equal, if animals move more, they're more active and then move faster whilst they're active, we will get more observations. And then finally, we get a group of factors here, which we can take account of through the measuring the effective detection zone. So if the vegetation is more dense, for example, we're likely to see less far with the cameras effectively. So that effectively gives us just 4 factors that we need to try and take account of. In the random encounter model, basically what we're doing is a detection corrected density estimate. Essentially works like this. So if we imagine a camera detection zone as this sector shape here, measured by its detection zone parameters. So in the last slide, that's what I meant by these. That's the radius and the angle of that sector. Then we have animals moving through the environment and randomly bumping into those camera detection zones. And those animals are moving at a certain speed, v, and they cover that distance, which is speed times the time. So let's say over the course of a day. And it turns out that that swept area there, so the profile of the detection zone and the distance traveled determines that swept area, gives us a relatively simple equation from which we can extract the density signal, based on those parameters. So the speed, daily distance traveled in this case, and the detection zone parameters, radius and angle. And then we've got the trap rate there, n over t, number of records per unit time. So how do we do that? So this is where we need the position information. So this is why we're doing all the digitizing in Agouti. Together with the depth model in Agouti, that gives us estimates of where the animals are relative to the camera. So we might see, if we plotted those positions, a scatter of points like this. And we can then use that to run distance sampling models in order to estimate the detection probability curve. And from that, we get the effective detection distance. So that's the effective distance within which we can expect to see. We don't necessarily see all the animals because it's a probabilistic process, but that's the effective distance that we can use to correct our trap rates to get a density estimate. And that then gives us our detection zone, something like this, fitted to those data. We can also get speed from those records. So by looking at tracks of individual animals. So each of these animals is creating a path over the ground, and we know where those positions are. So we link them together to measure the distance covered. We know from the timestamps where they've gone. So this is an example of a digitized track. This is what we showed in Agouti. And then we get a whole frequency distribution of speed estimates from that, and using an appropriate model to estimate the average speed, we get the speed whilst active. If animals are not active, they're not appearing on cameras, so as a rule. So we also need to take into account the activity level. So we look at the times at which animals are active. So we get a distribution like this, for example. This is a diurnal species. Fit a curve to that, and we get the activity level by manipulating the equation of that curve. And then the speed while active is multiplied by the activity level. Proportion of time active is gives us our day range estimate that we can use again in the density estimation calculation. So this is why we need this multi-step process in order to get all the way to our final density estimate. So once you've processed things in Agouti, the critical thing that we have is this hierarchically structured database using the camera trap DP data standard for camera trap data. And the fundamental characteristic of this is this, as I say, this hierarchical structure. So at the top of that structure, we have the location information. So this is where in space each of our camera traps is deployed. Linked to this, we have the deployment structure. So it's possible to have multiple deployments at different locations. For example, if you repeat things over years or replace a camera partway through a survey, that may become a separate deployment. So location is not exactly the same thing as deployment. It's worth being clear about that. And the critical thing is here that each table in our hierarchical structure has a primary identifying key. So in the top table, the location ID is the primary key for that table, and it is then linked to tables below it in the hierarchy by having potentially repeated values for that key in that table. So in this case, we imagine 3 deployments happened at that location at different times. And the critical information at the deployment level is when it started and ended. So that's what gives us our effort values, camera trap effort. The next layer, we've got the media table, and this is a row per media. So that could be video. In general, it's an image. So each image has a particular has a specific row, and the timestamp of that image is the critical bit of information here. And again, we've got the linkage to the primary key in the table above. And then for the REM, for REM purposes, we have, well, for any purpose, in fact, the bottom of the hierarchy is the observation table. But these observations have a slightly different structure to what you might have in any other table. So this is where we record what's going on with the animals. In fact, as you've talked about, you don't have to track every individual. You can sample, so you might simply have, well, I'll show you the next table down, but if you are tracking individuals, this is where you have the potentially multiple positions for each track. And this table is where that grouping happens. So this is an observation ID linked to the media above. So we imagine an individual moving over 3 images here and the positions of each of those. So each row here is one of those points digitized in a specific image. So this is the REM specific table that we need for grouping tracks. And then at the bottom, we've got the more general observation table where we group by events. So at this point, we've got the information about the species and potentially the speed. So if we've got multiple points, we can then calculate the speed from that and how many individuals. If you didn't track individuals, then we still get a record in this observation table with the counts. So those individuals then can still be accounted for in the density model. Perhaps if we're just taking a sampling approach to tracking animals. Oh, and then on top of that, we've got the project metadata. So there's a complex list of information, including such things as the name and ID of the project, the ownership, who's been involved in processing it, list of the species in there, and so on. So that can be also useful in just keeping track of where the data have come from, who it belongs to, and so on. So the real benefit of this is that it makes it much easier to produce tools that feed off this data structure and easier then to process in whatever way necessary. Those tools are still emerging to some degree, but there's now a reasonable suite of tools that are available for manipulating data packages and then, as I'm going to show you, produce density estimates from this kind of data. Hopefully that is all clear, but there are any questions at this point? Okay. So the next step then is the analysis. So the first thing that you're going to need, we'll be doing this in the R environment. So you need to install both the R analysis engine from that address and the R Studio user interface, which makes it much easier to run what you're doing. So that's the first thing that you need to do. Once you've got those 2 bits of software installed, first thing to do is to download your data package, which I think you've already talked about. So I joined a little bit late, I'm afraid, Tancredi, but I presume Jim's talked about downloading data and extracting the zip files for the data package. Is that right?
No, not really.
Okay.
He stopped at the very Agouti part. He probably didn't even show how to create the export file, even though that's very easy though.
Okay, so you've got that bit. So for example, yeah, so you just click create export, and then you can download the relevant file that you want to download. That should then be in your downloads folder. Okay, so we've got to that point. Okay, so if I click download here, and I go to my downloads folder, and see that I've got this zip file here with the data. So first thing that I want to do if I want to start analyzing this is fire up my RStudio. If I'm starting this afresh, this is a new analysis. I'll get this blank screen, really starting afresh. First thing I want to do is start a project. So, I mean, I could just start typing things into the console, but I don't want to run it from the console because that doesn't save any of my workings, and it's harder to pick up where I left off next time. So first thing I want to do is to create a new project. So if I go to File, New Project, and I'm going to create a new directory for this. So if I click New Directory, New Project, want to put that in, yes, that's where I want to be. So into my eNetWild EOW folder, and I'm going to call it Training Analysis or something. You pick something meaningful. And then if I create that project, should now be creating that directory. So nothing much changes there. Except that you'll see I've got now in my files, got this rproj file. So if let's say I close RStudio now, and I go to that folder that I just created. So you'll see that I've now got this project here. If I go back to my downloads, and I pick up that file which I downloaded, that zip file for the data, put it into my project directory. And then I unzip it here. Extract all. Best not to rename anything, because although the folder name looks a bit unwieldy, it does preserve exactly which version of that data set you're using, so it's worth maintaining that name. And then inside that, we can begin to see our hierarchical data structure. So it's a little bit simpler than what I showed you because Amtrak DP actually collapses some of that hierarchy that I mentioned. So deployments also contains the location data, so it repeats some of that information if there are multiple deployments per location. And then observations contains both the event level and the media level, so the digitization point observations and the grouped observations for summarizing over tracks. But the media table is exactly as I described. And then the JSON file is the complex project metadata. So You shouldn't need, you can open those up. They're ordinary CSV files. So if you need to go in and have a look, you can do that. But by and large, I would suggest not messing around directly with those data. It can be useful just to get familiar with what's in there. But as far as possible, I would suggest using tools designed for manipulating these data within the R environment. So how do we do that? So now I'm going to go back to my project directory root. Let's say that I've wanting to start a new session. All I need to do is to double click on my rproj file, and it will fire up my RStudio within that project environment. And now you can see I've got some more files. So I've got that zip file, I've got this folder here where I can see those data. So that makes it relatively easy to run. So what I'm going to do now is run through the example analysis that is on the CamTrap density GitHub. So I go to this address here, github.com, Marcus Roadcliffe, CamTrap density. CamTrap density is an R package that provides the tools for running REM analysis, feeding off CamTrap DP data. And if you scroll down here, you'll get to the README bit, and there is a detailed kind of tutorial there. So I just want to run you through this, give you an opportunity to ask questions, but at any time you need to refer back to this, it's available here. So I'll talk you through some of this. First thing you need to do if you're starting clean is to run some package installation. So the first thing you want to do before you start, as I say, is not to type anything into the console. This is the console here. See, it says console. I can type stuff in there, but nothing is saved if I do that. It's in the memory, but it won't be saved between sessions. I want to actually save a script file. So I'll go to new file, our script. And if I save that with some kind of meaningful name, let's call it that. So now I've got a script file here, which I can save all of my scripts in. So we will need to install some packages. So use the install packages. We can install multiple packages using this structure. So I would suggest you want the tidyverse, which is a suite of packages for plotting, data manipulation, and so on, which is generally very useful for a whole range of reasons, and is required for some of the constituent packages are required dependencies for CamTrap density. Some of the we need, so CamTrap density itself and CamTrap2R, CamTrap2R, are not available through this route. So we need to install direct from their GitHub development pages. So this is where we need these two lines here. So if I run these, yeah, okay. So I've already got them installed. Let me just show you what happens if I remove that. restart R, and now if I try to run this again, I actually cleaned Cam Chapter out, and now it's actually downloading it and installing. But you'll get this question here, so it'll find, likely, depending on how new your install is, it may find things out of date. Generally, it's fine to just ignore those. So just press return in the console. So put your cursor in the console so that starts blinking. Press return, and it should just start installing things. And even if things are perhaps not entirely in date, generally I find that's not a problem. Okay, so this, I'm going to put a comment in here. So you only need to do this install the one-off. Don't need to do this every session. So having done that once, I'm going to preserve it, but I'll just comment those out just to indicate that I don't need to run those again. So that the hash here means that that is no longer active code. If I run that line, it doesn't do anything. So that is just a comment. Okay, so what I do need to do at the start of each session, though, is load packages I'm going to want. So the main thing is that I'm going to need density. I use the function library. So if I just type library, CamChat density, that package is now loaded and I'm able to use the functions contained within it. Okay, so the first thing to do, the moment you can see my environment is empty, so the first thing, I've got no data to work with, is I need to load up my data. So I can do that by using read camtrap dp. So this is a camtrap density version of the data reading function. So this does some additional stuff over and above camtrap2r that's currently needed to get the data package into shape ready for density analysis. So we need to use this function for the time being. And what we need to do, so if I just type the bracket for that, we'll get a helpful yellow box here, which tells me what the arguments are. So each of those things separated by commas is what's called an argument. And the only compulsory argument we need to add here is the file. So that is a string of text surrounded by quotes, which points us to the file name. And specifically, we need to point to the JSON file, so the top level of the hierarchy containing the project metadata. And it'll find assuming that CSV files are in the same directory as they should be, and then all of the rest of the data will be found from there. So if I just go back to my project folder, open that up and I copy the JSON file. So if I highlighted the JSON file and I've copied it, you should find as if you need those quotes because they come as standard. So it will read in the path. So it's not giving me the full path because it doesn't need to, because my So if I get my working directory, you can see that by default, because I've used that project firing up file to fire up the session, my working directory is that project directory. So I just need to give it the downstream path below that directory here. So that's given me that path. The other thing I need to do, if I just run that line now, it will simply print all of the data to the console, and that's a mess. It won't save it, so that's not really very helpful. So let's say I'm going to assign it. So this is the assignment operator. So the result of this reading is going to be assigned to an object called package. So if I run that, I now have this object, and you'll see now in the environment area, it's got what's called a large list with lots of things. So if I look at that, I've got the profile, all of this metadata, lists of species, who was involved, so on and so on. Actually, yeah, too much to see within that environment. So the key thing there is, though, I can have a look at the contents of that by doing package, and then the $sign extracts different elements of that. So we've got all of these bits of metadata about the project, and then at the bottom, you'll see the data element. And within that, I've got all of these files now. So I've got the deployments, the media, and then I've split out the observations and the positions into separate tables. So that's the positions is the one row per point digitized, and then observations is the summary information across tracks. So that gives us what we need now, ready to start analyzing for density estimation. We can't dive straight into density estimation, though. We need to do some data checks. It's probably not that common that the data are absolutely perfect and ready to go straight out of Agouti. So we do need to have a look at what's going on with a few things. The first thing we might want to do is just to check that the deployment times all make sense. So there is a function called plot deployment schedule. And well, that just has one, that only requires one argument, and that is a data package. So one of these lists of data. And if we put that into this function called plot deployment schedule, see that now. Okay, we've got this plot down here. So if I, just to make that a bit bigger, you can see what's going on. This is what it looks like. So we've got locations across the bottom. And each of the black lines is the date over which that deployment happened. The orange ticks on there are dates and times of observations across that. And we can see the deployment ID as well for each of those. So that looks credible. We might want to look at what's happening with deployment B08, why it's so short. There's a bit of variation here. This is a slightly random set of data, random selection from a much larger study. So the deployments happened at different times in different places. So that's why they don't look very coherent. But otherwise, I might be happy with that. Sometimes what we see is that a camera has completely reset its time at the beginning, and it's got a date in 1970 or something crazy. In that case, we would want to try and do something about that. We might possibly go back to try to do something at the Agouti level, but that's not always the best approach. what we might want to do to be able to make progress with our analysis is to do something in Agouti. Another thing that might have happened is that the date and time were just set wrong. You see a deployment where you maybe the month was set wrong or something and it's out of place. Sometimes AM and PM are set wrong. So if you look at the beginning of this deployment, for example, and you see that it was set at 4 in the morning, that suggests maybe actually this is 4 in the afternoon, so that's fine. But if you see that it was set at the wrong in the wrong part of the 24-hour clock, then that's a suggestion that maybe there was a 24-hour clock error. That can be a problem because you remember we're pitting models to time of observation data to get our activity level, and if one or a few deployments have these errors, then that's going to mess up our activity schedule. So we just want to make sure that we don't have any of those problems. There are some automated tools coming through for some of these checks, which are just in the pipeline, but not, as I understand, quite ready yet. But they should be available soon. So we'll look out for those. But for now, there's just some manual checking needed. Once you've identified any errors, there's a few things that you can do to try to correct any errors. The other thing that you can do is to look at the spatial patterns. So you can just have a look at where your deployments are. So again, this is just a single argument. So if I run that, I get a map of my deployments. And if I refresh my Zoom, I should see. Okay. Oh, I forgot to mention that in this deployment schedule, you can zoom in. So if I want to look a bit more closely at those two, I can see what's going on there. I can pan those around and so on, reset the view. So if you've got a lot of deployments with a lot of very dense information in your data package, it can get hard to see what's going on. This can be very useful for looking at subsets of your plot. I'm just going to do this within this environment, but I can zoom in and out. So this is in Cornwall, Western England, and that looks pretty much where we expected our deployments to be. So let's say that's a subset of a wider study. If you prefer to have the second argument is the base map type. So you can run a satellite version of that, which might be more useful depending on where you're working. You can also map trap rates. So same idea, but so now it wants to know which species. So it's given me this table of species. So I'm going to say, let's have a look at Vulpes. So that's species 40. If I enter the 40th row, now it shows me where the foxes are mostly clustered in that data set. So that's a useful kind of first look at where things are. It's not a very flexible mapping system at the moment, but it gives you at least a first look at what's going on, which can be quite helpful, just to make sure everything's in order and the location data are in place. It's worth saying that if you haven't input location data into Agouti, so there's location data missing. It won't be possible to actually import the data into R using this this function, because those data are required for some of this functionality. So it's necessary to have that available. Okay, so going back to what to do with your deployment schedule, let's say you have you've identified some problems with your deployment schedule, and you want to fix some things. So let's say this deployment here was a month out. It should have been a month later. So we can make a new package. Generally best to make a copy rather than overwriting, at least in the exploratory phase, so you don't get confused about what versions you're working with. We can use the correct time version functions. So then we give the package to that. And then we need to know which deployment ID we're applying that to, or location name. You can see, if you look in the yellow box there is the second and third arguments are dep ID and lock name. So you can do it either by deployment ID or location name. Deployment IDs are obviously long and complicated, randomly generated collections of characters. So it's generally easier to use location name if you can, but as I say, it may be that there are multiple deployments at a given location. In this case, the location name is specific to the deployment, so we can just use that. So if I now name the argument, so yeah, just to say that I've been just putting the package in here, but if you want to be, and the way that function calls work is that if you don't explicitly name the arguments, it will expect them in the order that they appear in this yellow box here. So if I were to put two arguments in here without naming them, it would expect them to be the package and the deployment ID, dep ID, in that order. If I need to ignore something, one of those arguments, and then put a new one in, then I have to name them. So the first one is okay because it's always at the beginning, but now I need to name that. So that will be lock name equals, and then B01. And then the key thing here is that I need to give it 2 more arguments, and these need to be named again. So wrong time is going to be, let's see, so the beginning was, I can see the timestamp for the very first observation there. So let's assume that was the setup when people were putting the cameras up. So I'll give that the date and time in this format, exactly as I see in the box there. Then I give it the right time, equal to 2019, and then actually, let's say it should have been June and not May, but otherwise everything is the same. Okay, so let's try running that. And then if I just check what's that has worked as intended. Okay, so keep your eye on this. Remember, this was in around about the beginning of June. So if I now, oh, sorry, oh yeah. Yeah, that's right. It was around about the beginning of June. I've pushed it back by a month because I happen to know that that was out by a month. And then I run this new plot. We'll see that that's shifted up. So maybe that's where we should have had. So that gets things in order. As I say, we could also use that to, if it wasn't the month that was out, but let's say it was set at 04, we had an AM/PM mix-up, we could just correct it using this sort of setup, shifting from morning to afternoon to get that to the right time. So much smaller shift, but maybe important to get the activity patterns right. The other thing we can do, if you've got a large project with maybe multiple surveys in it, or you only want to analyze for part of your survey area, and you want to maybe pick up just a subset of your deployments, maybe that yeah, so I just maybe want to analyze maybe these ones in the middle here, so the ones that were set up around the late May, early June. Let's say that I want to just select those. I'm going to create a new package, and I'm going to use the functions subset deployments. Again, I'm going to go back to the original package just for illustration. And we've just got this thing called choice here, which is quite flexible. So what this does is creates a logical expression based on fields in the deployment table. So I'm going to, if I want to know what those are, I could actually have a look at that. So I can look at my package, I can look at my data, I can look at my deployment table. If I run that, we can see what these fields are. So you've got deployment ID, location name. We've got the start and end deployment dates. So these are the key things that I can choose by. Okay, so so the first thing we could do is to say, or maybe we just don't want. So we could, yeah. We want to throw out one of those deployments. That would be the simplest thing. So that's going to be location name not equal to. So the exclamation mark means not. If I wanted to just pick one deployment, if I just wanted to pick deployment 01, for example, I would do a double equals. Wouldn't make much sense because then I'd have a data set with only one deployment in it. But if I want to just throw out one, that means not equal to the 01. So I run that. I have a look at what that's done. That's thrown out B01. So I can just throw out one package that way. If I want to maybe throw out several of them, I can use this function. So this is this operator called in. Then I have a set of ones that I want to throw out. So let's say I want to throw out B02. 4. E17. E14. So that's just selecting those ones. If I don't want to select those, then I put the negation here. So that's saying location name not in any of these. Make sure you get your spelling and case right, because it matches on those. So if I try that and have a look at that, then it's just left with those ones in the middle. So there might be a simpler way to do that. I don't know if it's simpler or not. But to do this, we need the Lubridate package. Oops. So we load the Lubridate package. This helps us to work with time and date data. So now we can run a version of this where, rather than working with names, we can say start is greater than, here's the start here. So let's say 20th of May or 23rd of May at midnight. So we need this Lubridate function. So YMD, that's year, stands for year, month, date. If we just say 2019, and is less than, let's say, the beginning of this. Let's say the 8th of the 6th. So if I run that, so that's saying just include deployments that start after that date and end before the end date given there. So that gives me exactly the same result as I had with that name-based. So there's different ways to manipulate them there. You can also slice deployments in half, so you don't need to select whole deployments. You can cut up by time, but I'll leave that for the purpose of just moving on a bit more quickly now. But you can take a look at the README help files, information in the GitHub directory in order to see how those work. Hopefully that all makes sense. So next up, I'm just going to go back and put a few comments in just as good practice, just to show what that looks like. It's always helpful to have some comments so that next time you come back to a mass of code, you can see where you've got to. Actually worth pointing out, nice little trick is that if you start building up a big code file, if you put a comment in and then trail it with 4 or more hash signs, you click on this little list sign here, you then start to build up a navigation list so you can quickly see where you've got to. So if I add another one, so let's say the next thing is to check how correct deployment times. Go. If you put additional leading ones, then it gives you a hierarchy of headings. So that's quite nice, quite useful, I find. Okay, so that's where I've got to here. Let's have another heading. Check deployment calibration models. That's the next thing. Right, so you can see we're building these up. And as I say, these are clickable. So if I click on the read data, that takes me to there. I click here, takes me to the correct deployments, and that takes me straight to that heading. So that's really helpful for navigation. What we need to do here is, before we actually start analysis, is to check that our deployment calibration models have worked. So this is the depth perception element of the Agouti process, which is based on the pole digitizations. So what we did in taking those pole digitizations is gave Agouti the information that it needs to extract position information for the animals once we digitize them. But if we have a bad deployment calibration model, it may still give us position information, but that could be very badly biased. So we need to make an assessment of how good our deployment calibration models are. And to do that, we use the function check deployment models. That's what it says in the tin. That's a very simple input. Again, it's our package. So let's assume there was nothing wrong with our data package, in fact. So we're just going to use the raw input. And we need to save that to a new object. So I'm going to call it package checked. The reason being that we're going to step through all of the deployment calibration models, and we're going to see how well they fit. And we're going to make a decision as to whether we want to use them or not. If it's a bad model, that doesn't mean we throw out the whole deployment for the purpose of density estimation. We can still use the observations for the trap rate information, but we don't want to be using the position information for estimating speeds or effective detection zone parameters. So that's what the process does. It saves our choices, and then at the next analysis phase, that saved information is used to include or exclude the position information from the appropriate models as appropriate. So what happens when I run that? So we get a plot like this, and you can see down in the console now, we get a question. Use deployment, do I want to use it? So it's asking me to put in a yes or a no. And we have a plot like this. So I'm just now going to flip back to my PowerPoint and talk a bit about how to interpret these deployment calibration plots. Worth mentioning that, I'm not sure if Jim pointed it out, but whilst you're, actually, let me show you. Worth reiterating this probably, if even if Jim already mentioned it. So whilst you are processing your information, so let's say I've got my calibrations here. So in digitizing the poles, It's a slightly wobbly one, but we have this button here, preview plots. So you can see, actually, I find this sometimes doesn't work. In theory, this should give you calibration plot. In practice, I find it sometimes takes a long time, sometimes hangs. And okay, we get there in the end. So this is what a version that we saw in the R console as well when we brought this up. This gives you, once you're, this is quite hard to see, you can click on it and enlarge it. This gives you a kind of a bit more instant feedback on what's going on. So if there are problems, things look bad at this point, we can perhaps correct them already in Agouti before we export the data. So if you can do that, that's worth doing. But how do we detect problems? What does a bad deployment model look like? Okay, so going back to this, first we need to know what these plots mean. So basically what I'm doing is plotting distance from camera on the y-axis against relative y pixel position. So in this case, the points on these represent one digitized pole. So we put 2 positions on that pole. This represents the distance of the base of that pole from the camera. And on the x-axis, the y pixel position is how far up or down the image it is, starting from the top. So 0 is the top of the image, 1 is the bottom of the image. So this pole was at its base very close to the bottom of the image, and it was about 1.5 meters or a bit less from the camera. And the lines here are the model fit. Okay, so that's giving us an indication of how well the model predictions fit our lines. So in this case, this example here was, yeah, just under 1.5 meters near the bottom of the image. And we've got a very nice flat ground surface here, and the horizon is fairly level across the camera. So this is the kind of model fit that we expect from that. So it's been well carried out. There's been a fair number of poles across the different parts of the image, from left to right and front to back. And so we just get effectively a single line here that represents the regression in distance from close to at the base going to further away. And at some point there is a horizon somewhere a little bit above the middle of the image here. And so this is the point at which the lines disappear off the top of the image, an accelerating point there. So this point of the disappearing point around about here, as I say, a bit above the middle of the image, represents the horizon. So hopefully that makes sense in how to interpret these models. So as I said, this looks like a nice model. We've got a reasonable number of points. There's about 10 or more. That's sufficient. Should be. They look to be fairly well distributed, both across the y pixel position, this axis here, and left to right. So the left to right is given by the shading. Darker points are, so this is the small print here, shading from left to right with darker points on the left. So that gives us, some confidence that this is a reasonable model. The points are all pretty close to the lines, and the lines, let's say they're all together, so that represents a fairly flat, smooth surface, nicely fitting model. So the conclusion for that is that I would say, yes, I like that model. I'm happy to use it. What we might see is something more like this. So this is plenty of points again, so reasonable number across the range of y pixel positions. Also a spread left to right, so we can see this gradation of darker points here towards the left, and paler points here towards the right, and the lines fitted accordingly to those points. So the grey points are nearer to the grey lines. So that represents the separation of the lines there means that there's more sloping ground here. So the horizon is probably not so level. But that's not a problem. That should still give us reasonable predictions. The main thing is that the points are reasonably close to their appropriate lines. And as I say, we've got sufficient points. So again, I would be happy to accept that calibration model. Okay, so I think hopefully it should be fairly obvious that that is not a good model, but there's a few things wrong with it. There's only 3 points, so we're always going to struggle to get a good model in that case. Sometimes you might get something that looks reasonable, but even if it looks reasonable, you're likely to have a very poor spread of points across the range of Y pixel positions. So it's not likely to be reliable. In this case, it's clearly not reliable because points are a long way from their respective lines. With so little data, the model has struggled to come to a good fit. And the extreme spread of the lines is pretty unlikely. So that suggests you're more or less on some sort of cliff with the horizon way off the bottom on one side and way off the top at the other. So in theory, it's possible, but it's not all that likely. So I would reject that model. That's quite a poor model. So this is an example where it looks like that potentially could be a more sensible sort of trend line. But again, we've got really few points, so I wouldn't want to rely too heavily on that sort of trend based on so few points, just the 3 points there. And the points are fairly far from, not as close to their respective lines as I would hope. So again, I would be suspicious of that model. This is somewhere in between. At the moment, it doesn't look like a great model because we've got points a long way from their lines. Most of the points, though, look reasonable. So they're giving us a fit that we could believe. The shading, the points in this region here seem to be close enough to their lines that we could have some faith in that. But we've got these 2 outliers. And that could be for a couple of reasons. It could be because we're on extremely rough ground and there's a smoother area here which fits these points nicely, but then a pole's been placed. So what would you say? This is way too far down. So maybe there's a ditch close, a few meters from the camera, and the pole's just been planted at the base of that ditch or something, a crack in the ground, and it's given rise to this. So the other reason is that there's been a digitization error. So the wrong height's been given for one of the points, one or more of the points, and that's messing things up. In either of those cases, certainly if there's been a incorrect height entry in Agouti, you can fix this by going back and fixing that digitization and re-exporting. Ideally, you would have picked this up, as I say, within Agouti, so using that plot preview function to check before you finish the pole digitizations for each deployment, just to head off any of those. And again, if it looks like the ground is generally reasonably reliable, but there's just some very rough bit and there's a pole in a position that might give you a really poor prediction, then you might want to just exclude that pole and not use it for digitization. So yeah, that one I would reject at this point, but potentially might be salvageable. Check it in Agouti, ideally before export, but if necessary afterwards, and go back and fix it. Okay. So that's how to interpret these plots. So this is a bit borderline. We've got rather limited spread across the y pixel position axis here. So you could try it out in different ways and see how much difference it makes. My experience is that usually most deployments it's fairly clear whether it's good or not, and then if there's a handful in the middle where you're not sure, it doesn't generally make too much difference whether you include them or not. So I generally wouldn't agonize too much. So let's say I'm going to exclude that one. Reasonable model, perhaps, but in terms of its shape, but too few points. So I'm going to exclude that one. I should say this was not a very well run model, so I may end up excluding them all. In fact, and I've only got 3. So actually, I'm going to rerun that. And just for the purpose of being able to make some progress, I'm going to include them all so that we've got some data to work with. But it's going to look pretty poor. So don't take this as an acceptable way to run your density estimation. Ideally, would be wanting a lot more good deployment models and therefore good position data to work on. Okay, so.
Sorry, Marcus, for interrupting. There is a raised hand. I don't know if Valerie is willing to put a question.
Yeah, sure. Sorry, I didn't spot that.
Yes. Hello, Marcus. I just have a quick question. For the wrong poles, how can we easily find them to remove them from the calibration on Agouti? How do we have to do it?
Yeah, that's a good question. So, so I think you just need to, you need to know how to interpret these. So you're looking for a pole that's, in this case, let's say it's 5 meters away. It's on the left of the image, and the base is a little bit below the bottom of the image. So you just need to make a mental image of that pole, and then when you're flicking through you can use this dialog here to flick through your annotations. So that's too close. So that's not 5 meters, but otherwise it might be roughly what we're looking for because it's the base is a little bit off the bottom and it's towards the left-hand side. Does that make sense? It should, you'll have a limited number of them, and so it should become fairly obvious which one is causing the problem.
Okay. Yes.
Yeah.
Thank you.
And as you go through, you can also check the heights make sense. So, the checking that they match up. You've got 0.4 and 0.2 here, for example.
Okay.
Makes sense?
Thank you. Yes.
Yeah.
Thank you.
Okay, so I've done my check. So this is the final phase where we actually get to produce a density analysis. So in principle, this is quite straightforward. So I'm going to create a new object. Let's call it estimates. If I do REM estimate, that's what I want. Just get my reminders set up. There we go. If I had rejected some deployments for position information, I would need to use my checked, but let's assume that Oh, well, yeah, I've said yes to them all, so it comes to the same thing. But, let's use that. If I just run that, I can simply run that. So that is saying make an RAM estimate based on this package. I will get the dialog that I saw before. Oh no, okay, yeah. So what it's doing is asking me to rerun that. So it forces me to rerun that. I don't want to do that every time. So this is, again, it's asking me to run those. So I'm going to put in my cursor in the console and escape from that. Mind myself. So this is check deployments equals false. So the default is true. So I want to switch that off because I'm using a package which I've already checked. So that's saying that I don't have to run this every time. I can just save that package. Actually, that's worth. I'm just going to take a little step back and show you how you can. So you don't have to run this every session. So you've had enough for the day. You want to shut down and go to bed, or do something different. But you don't want to lose that work you've done, maybe slicing the package or checking the deployment models. So you want to save that. So you can use this save function. That's a base R function. And you can save that object. So this is the object that I've created. I want to save it, and I want to save it to a file. Let's give it the same name so we can easily keep track of where it comes from. It's a bit tricky if you start giving things different names. And we give it an RData extension. We know what kind of a file it is. So if I save that, we can see that in my project folder now we have this new file, so package checked.rdata. So that's saved and ready to reuse. So if I just to imagine that I've restarted in a new session. In fact, let's create a new session. So I'm going to restart R. So imagine I've just gone to bed, come back and started a new session. I start again with an empty environment. And I want to not have to redo all of that checking. I can then load that file. So load that. It just springs right back into my environment and it's ready to go again. So now I can run this REM estimate. Yeah,
Marcus.
Yes.
Sorry to interrupt you. There's another question in the chat, but unless you prefer to do otherwise, I would say that you can finish and then everyone can ask you whatever doubts or questions they have. Or unless you prefer to answer them on the way.
Yeah, sorry I didn't spot that, but I think better to take them kind of chunk by chunk. So whilst we've still got deployment calibration plots in mind, let's go back to that.
Okay. Okay.
So looking for the slope. So sorry, Tricia, can you just elaborate slightly on what you mean? I'm not quite sure which elements you're referring to there.
I think you said something about the that the slope has to be some kind, or did I misinterpret that? If it's too flat or if it's too something, that's the point I didn't get.
Yeah, so there isn't a a specific shape that it should be, but there are some shapes that are a little bit unlikely. So that, for example, so the right hand side of the image, so the pale grey line there, that would suggest that basically you're looking at a cliff's face, right? So there's no regression to the horizon. That line is almost flat. So that means that every point in the image and the Y pixel position, so the vertical position on the image, every point is almost exactly the same distance. Whereas on the right of the image, the black line, there is very rapid regression to the horizon. That's what it suggests. And that horizon is not even visible on the image. So it's just that is not a realistic pattern in the data, really. So a realistic, in reality, it's very unlikely. It's theoretically possible, if you're working in a ridiculously steep terrain, and you've got a cliff face on one side that rapidly gets less steep to a nice flat, looking across a flat slope on the other, flat piece of ground on the other. That could happen, but it's not very likely. But in general, so the steepness of those lines represents how the ground is relative to the camera, and there's a whole range of different steepnesses of those lines that could occur. It's what you're really looking for is how well the points fit those lines, and therefore how well you've characterized that shape. If you've got a reasonable number of points and they've been well digitized, the ground isn't too rough, then you should get a good characterization of that line. So, but broadly, usually the sort of thing that you're looking at with a good placement is something like that, with the lines not too far separated and with some sort of regression to a horizon characterized by that disappearing off the top of the plot there. It does take a little bit of getting used to thinking in this way, understanding what those plots mean, but hopefully that broadly makes sense. Does that help you out, Trishna?
Yes, it does.
Okay, cool.
Thanks.
Okay, so back to analysis. I've reloaded my data, got my REM estimate function, because I know this is a checked package. I want to switch off the deployment checking so I don't have to do that all over again. Oh, yep, sorry, okay. One thing you do need to do at this point is reload. My capture out density functions, so that library. If I reload that, so now it's working. So the first thing that happens is I get this table. There's a whole load of species. And I get some summary information. So this is the number of sequences. I've got 16 sequences of fox, for example, Velpies, red fox. Each of those is presumably a single individual because there are the same number of individuals. Sometimes, so for this species here, we had more individuals than sequences, so we had some sequences with multiple individuals passing. This is a worry, but we're going to struggle to get good models because we've got so few data. We should be able to do something, but it's clearly not going to be reliable, but it should be enough for illustration purposes. But even with including all of the calibration models, we've got a limited number of position data and speeds. But we've got some, so let's see what we can do for Fox. So again, I say row 40, that's going to give me Fox. Saying I'm analyzing Fox density, it's fitting a radius model, fitting a speed model, angle model, an activity model, calculating density, and then it's done. And now I have this object called estimates. If I look what's in there, you can see in the environment, it's a list of 12 different things. So I've got the data, so that's the trap rate data. So for each location, how many observations there were and so on. I've got my estimates. So I'm not going to look at those for the moment because we might want to look at some other things. Some basic information about where the data came from and so on. But then these things here, so the speed model, the activity model, the radius model, and the angle model. So these are the component models that give us our trap rate correction factors, essentially. Enable us to go from trap rate to density estimate. So the first thing we might want to do is a little bit of model checking. So we can plot some models. So we can look at our speed data. So we can use a version of the histogram function, which works specifically on speed model objects. So if I take my estimates, take the speed model element of that, I can run that function. That is really not very useful at all because, as you can see, we've only got one observation, so it doesn't really make much sense to run that. But it has been able to run, but I really wouldn't rely on that model very much. That'll be much more meaningful if you have enough speed observations to do something sensible with. You'll be able to look at the distribution, check for outliers, see whether there might be some issues there that you might want to correct. And there's various ways that you can then streamline the data potentially to give you more robust models. But hopefully that looks all right if you in your own larger data set. For other models, we use the plot function. So not the base plot, but a version of it that applies specifically to these models. So the radius model in this case, and we want to use PDF equals true. So we want to plot the probability density function of our radius model. That looks pretty horrible again because we've got so few data. We just had the two observations. Can't really fit a model for that. It's done it, and technically you can, but in practice it's not going to give you a really sensible estimate. But let's just proceed for now anyway. Similarly, do the same for the angle model. So this gives you the PDF, or the probability detection by default, which makes sense for angle models. And then we can look at the activity pattern. Activity model. So, yeah. Not entirely nocturnal, but primarily, as we would expect for Fox. But, we had too many diurnal. Normally, we expect foxes to look pretty nocturnal, but you had too many daytime photos there. You might want to check again on where they come from and whether the times have been set right. But broadly, that looks okay. But again, rather few images, so or few sequences on which to base that pattern. So We might not want to rely on that too much, but assuming everything was okay there, what we could do then is to extract our estimates. So that is the estimates element of that. So that gives us our table. So we've got an estimated radius of 1.7 meters, an estimated angle of 50 degrees, an active speed of 3.94, that's about 4 kilometers per hour. And we've got a missing value for standard errors, which then propagates into missing values for standard errors in overall speed and density. Because, of course, we only had one observation. So the n here is the number of speed observations. And you can't calculate a standard error of sample size of 1. So it's nonetheless given a result, but obviously it's not really very reliable if we're not getting a good estimate of error. We've got a 28% activity level, proportion of day active. From that, we get an overall speed of 27 kilometers a day. Sounds like a lot, and probably is. So again, that's probably down to this tiny sample sizes. We got a trap rate of just under 0.1 records per day. So that might be credible, and then a density estimate of 2 per square kilometer. And then the sample size should be missing for the density because it's a composite with different sample size for different elements of the model. But the trap rate sample size here is the number of deployments from which that originates. So that's the key thing that makes the difference here. So then that's all the information you need. If you're doing multiple species, you might want to do a different version of this. So rather than choosing from the table, although that's useful for seeing what kind of sample sizes you have, you might actually want to specify the species. So in this case, we could get the spelling right for the species name. There we go. Maybe give that object a name. So we could just so if I run that, it just goes straight into the analysis. Okay, so it's so I don't know why it worked when I specified the species from the table question, or when I'm actually specifying it at this point. Now it's struggling. It's just a very small sample size problem. But you shouldn't have that problem in practice if you've got enough data. Let's say we now want to report those estimates to the EOW. We can use this function here, write REN CSV. I don't give it a table, I just give it the whole estimates object. That tells me that it's written this file here. So it gives it a meaningful name, so we know where it's come from. That's the data package information running all the way through. So it's all traceable. And if we go to our folder, you can see that it's created this CSV file here. And that's the information that you can then report to Tancredi, enabling it to be added to the central database. That essentially is it, I think. I'm sure there will be questions, which I'd be happy to answer. But as I say, This process is all detailed in the GitHub for the ChemTrap density package. So this gives you sets out all of the things that you can do in some detail with a little bit more explanation as well. So hopefully that all makes sense. I'm sure many of you have already been through this to some degree, so it wasn't all completely new. But if there are some for whom it's new, then and anything is unclear, then please just give me a shout, or if it's questions about implementation, anything at all. That's all I wanted to say at this point.
Thanks, Marcus. I think, well, thanks as always. It was, I think, extremely clear and exhaustive. And well, on my side, I would like to ask you whether you could give a couple of more details about the numbers which are required to have solid results, let's say, because Jim mentioned to some extent the number of observations which are needed, but yeah, I would like to make clear the the difference between a minimum number and an optimum number, and because then this makes a big difference in when putting together the database with the quality of the results that we get.
Yeah, definitely.
Thanks.
Can you tell me what Jim said so I don't cause confusion by saying something different, slightly different or very different? I'm sure I won't, but it'd be useful to start from that point.
Sorry, say again, please.
Do you remember what Jim's recommendation was? It would be good to start from that point,
yeah,
so I'm congruent with what he's saying.
No, sure. Yeah, he mentioned like about 40 observation as a minimum number to get reasonable estimates, and yeah, so that was, let's say, the starting point, because that's the minimum number, not the what we really think would be ideal. So perhaps that would be okay if you don't have anything else to get an actual estimate, but yeah.
So yes, that I would say is about a minimum. Optimal, I would say 1 to 200. Obviously, this all takes time, so adding an additional 50 or 100 observations does take a bit of time, but it's not inconceivable. At that point, you're just it's a few seconds per track, or maybe a minute maximum. So it's worth putting in that extra hour or few hours to do that, to get really robust estimates if you're able to do that. And you have enough records, of course. If you're trying to do it for species that are not so abundant and therefore giving you fewer records, all you can do is try to digitize everything and then do your best to get estimates out of that. But if you've got only, let's say, 10 or 20 records, you might end up with fewer speed and radius estimates from that. That's definitely going to give you quite sketchy density estimates. The error on those should reflect that, so you'll get usually very wide confidence intervals on your density estimates, and that's not unreasonable. So I mean, I would say that doesn't make them completely useless. There can be still some information in there that could be useful down the road, but so I would say if that's all that you can do, because that's all that the survey gave you for a particular species, it could still be worth reporting those. But when it comes to, if you have a common species where you have many hundreds or thousands of sequences of records, which is possible, and you can't be digitizing them all. If you possibly can aim for digitizing at least 100, maybe up to 200 of those sequences, then that'll help to give us really good, precise, robust density estimates at the end of the day. Question is how to take that sample, of course. I don't know if Jim talked about this. Did he have selecting which sequences to track?
No, not actually.
Okay. So we need to try and get a random selection across locations and times. So for those, so we don't want to be just digitizing the ones that look nice and easy to digitize. We want to be picking some sort of random selection. So the suggestion is to use the observations table. So rather than in the deployments table, so obviously you want to be checking the classifications, so all of the observation, checking that all of the observations look sensible in terms of their species classifications, using the deployments annotation, so stepping through sequence by sequence. However, for sampling sequences for digitization, what you might want to do is, let's say I wanted to so I'm going to the observations interface here. So this is a list of all my observations. So I've just got 67 here for sheep. And then if I sort by observation ID, because the observation ID is a random collection of characters, it'll put them in a random order. And then if I just start sampling in order down this table until I get to 200, that'll give me a nice random selection of observations to digitize. So in this case, I've got an observation of 2 sheep. If I edit it here, so on the right there's an edit button, and I want to select one of those individuals. So I do need to make a choice here. In fact, let's go to a more tricky one. If it's a single individual, just need to wait for that to refresh. Just need to refresh that by typing the name in again and resorting. So if I have a single individual, then I can just digitize that. If I have lots of individuals, I would just take one individual from that. So let's have a look. Right, so we've got an interesting case here. All of these individuals at the back are clearly not going to be actually usable. So the camera would not have triggered for those. They're clearly too far away. The animal that did trigger it is here. So we have an obvious choice here. We want to try and digitize that animal. So either if we had some other individuals that were equally close to the camera, then we could say that they were also available. So in this sequence, yeah, that's all we have. We just have this one individual close to the camera. Let's say there were 2 or 3 individuals who came through at roughly the same distance and could equally have triggered the camera. We just pick one of those at random. But we want to exclude those. So in this case, we've just got the one individual. So we want to edit this observation. Say that it's just the one individual. And then I want to digitize roughly where that individual is. So on this image, it's grazing. I can imagine the sheep's body around here. So say its position is there. If we're plotting them down the bottom here, it's not too sensitive to exactly where I put it. So that's probably an adequate assessment of where that individual is, maybe something like that. And then I could save that. If there were more individuals coming through that could have triggered the camera, I wouldn't want to track them. I want to just sample one individual from each sequence, but I would need to add an observation in this case of Ovis. And let's say there were 2 more individuals that came through. So now I have 2 observations, one of which is a single individual that I've tracked, and then one of which is 2 more individuals that I hadn't. I'll just delete that because actually there are no further individuals that came through within that, within kind of camera triggering distance. All of the additional individuals up the back there are clearly too far away. And so on. So hopefully that makes sense. Maybe there are questions. There's something in the chat. Any questions about that process for sampling for digitization first?
Well, one thing, maybe if I can just speak, Marcus.
Of course, yeah.
That one photo that you just shared of this Ovis, I would not even digitize it.
Yeah.
But is that something? Yeah, because it's like the whole body is not available and I would just have to guess. I would just not even do it. Or was that just demo?
No, I would make a stab, because you can digitize outside the frame, and as I say, once you start getting towards the bottom or off the bottom of the image, basically you're just going to get very close distances, and it's important that those get registered, right? So if you don't digitize those, then we don't get such a good model fit, telling us where those observations are. So it's important to have that information in order to give us a robust effective detection model. So I think you need to make a bit of a judgment call. If all you see is the very tip of a tail or something, and you have absolutely no clue how the animal is oriented, then yeah, maybe that's a good reason not to bother with that one. But if you can make a reasonable guess about how the animal is oriented and where it's the base of the animal is, so remember we're looking for the base of the animal, and you can make some sort of educated guess as to where that is, it's worth having. Does that make sense?
I have a whole bunch of questions. Yes. Can I also put them in the chat, but can I just go through them one by one?
Yeah, that'd
Maybe
be
it helps.
good. Yeah.
So one question I had is, can we get some estimate per camera? Because we're also measuring some site covariates on like the ground vegetation, the canopy openness, I'd like to look at things like distance from roads,
Yeah.
etc. Can we
for
get
sure.
something?
Those methods are in development, so they're not widely available. The statistics is still being worked out, but in principle that is possible. But it's not implemented in chemtrap density yet. So I think to do that we need to take that. We need to. There's further work needed. So I'm been thinking about it for a while, but don't have the accessible tools available yet. I think others are working on the solutions for this as well. But I'm afraid I can't give you a nice ready-made recipe for doing that at this point. But basically, it comes down to making your own linear model of trap rate, but incorporating the other model parameters in an appropriate way into that model structure as well. It's a form of hierarchical model that builds that in. But I'm afraid you'll have to hang on for a little before we can actually give you some good guidance on exactly how to do it.
So if I was to try this on my own, should I be using like the encounter rate as the as the variable to model? Because I won't get density estimates any case, right?
Yeah, I mean, if you the only I mean, essentially encounter rate, trap rate runs straight through into your density estimate if your other parameters are spatially constant. So if you want to look at whether abundance varies in space and you've modeled these, so it's possible to run models. So I should say that. So going back to R, so let's say you want to run a model where you fit your radius model. So you can actually fit this with a formula. So you could say, I'm not going to try and remember the exact syntax. I'd need to go and check. But you could make this a function of covariates, for example, more open or closed habitat. You could then use the predictions of those to have different detection functions, different detectabilities in different habitats, which might be very useful for then controlling or explaining part of the variance in trap rate, teasing that out from the density influence. If you find that there are no statistically worth bothering with differences in detectability across your study site, then there's no reason not to simply analyze relative abundance using trap rate linear, widely available linear models of your trap rate, basically. And you could use the trap rate table that comes out of your REM estimate here to give you your raw data for that. You just need to add in your covariates to that table, and that would then give you a data frame on which you can build a linear model for relative abundance. Does that make sense?
Yeah. Maybe I'll get back to you once you've made the first few trials and ask you to see if this makes sense or not. Yeah. Cool. The second question I had was, we are working with one species that is really common, the roe deer in Germany, and we have really low estimates. We just ran the very base model, didn't play around with anything, but we are getting something like 3 roe deer, and when we talked to the foresters, they were really shocked that this is what we are getting. But how can we? They
expected it to be much higher, did they?
They expected it to be like something around at least more than 10.
Yeah.
And and what follows up in the project is that we're going to have an open discussion about these results and also what they perceive it to be. Like, what can I do to make sure that this is like not an artifact or a mistake, or can I run something else to see? In some cameras, for example, we have this issue where the camera had to be placed a little higher than recommended, and we don't have, this assumption that the detectability is 1 in front of the camera is not met in some of the cameras. Not many, but still there are like 2 or 3 cameras out of the 40 something that we have. So I'm just thinking, should we play around with those, or is there a simpler method to kind of?
Yeah, I would definitely look at your component parameters, so the speed and detection zone estimates. So plot your model distributions, see if you're getting outliers, seeing if the model doesn't seem to fit very well, and whether there's something you can do about that. So you can change the truncation for your detection radius, for example. If you do have their cameras are a bit high, and you have a zone in front of the camera where animals are getting missed. I mean, roe deer, it seems not so likely, but maybe possible, I guess. Certainly the smaller ones might be disappearing under the camera. So you might want to have a left truncation, so you can do that if you use this fitting the models separately, as in this example here. You can add truncation information there, so the dots in the arguments there enable you to pass those to the distance, the ds function. So basically, under the hood, it's using a ds function. So you could change the truncation using the standard ds notation arguments there to try and make sure that model is robust. So it's possible then that you're overestimating detection distance, which would then underestimate density. So that's possible. Speeds, if you are overestimating speeds, that may be the case if you've got some poorly fitting detection, some poorly fitting deployment calibration models giving you some excessive distances that are giving you too high speeds. That's possible. So you might want to double check those and see that those are all as tight as you can make them. The other possibility is something to do with the survey design. If it's been, the animals are extremely selective in their space use, and they're using some quite rare habitats very intensively, and by chance you don't happen to have hit those, it's possible that you end up with a underestimation of density through that. So it's not possible to simply, click a button and test these kind of things. It's a qualitative assessment of whether the assumptions are met, whether the models fit well, whether there's something like that going on with space use relative to camera placement. So you just have to assess that on the basis of what you've got. So partly, on that last one, camera animal distribution spaced in space, and how concentrated it is, that's partly kind of expert knowledge. If the managers know something about that, and something about where the cameras are, and there seems to be some sort of mismatch there, that could help. If you see some sort of very highly skewed distribution of records between camera traps, then that can be indicative. Again, you just have to take a whole range of things into account and try to make a judgment on that basis. And then it becomes an interesting discussion, I think, with the kind of local knowledge as to where the reality lies. And I think it can bring a bit of healthy debate and questioning both into their knowledge, not to be challenging and make assumptions about who's right in it, but it can help to challenge that, but also challenges the assumptions that you've made in the modeling and whether they're justified.
Mm-hmm. Yeah, two other technical questions, I guess, before I jump to something else is, we often have problems with the date settings, and we always mess this up. I mean, now we're better after a year, but we often do the month and date reverse, or the time is AM, PM is wrong.
Mm-hmm.
I'm sure a lot of people have these issues.
Yeah.
We've been fixing it with the EXIF tool and then uploading it onto Agouti. But I just saw you showing that we could just do it post hoc using the Lubridate package. Do you recommend one or the other?
I think if you've got a good pipeline for doing it upstream with modifying the EXIF data so that it's all done and dusted by the time it's in Agouti, that's probably preferable, because it's otherwise if the data are downloaded again for another purpose at another time, you have to repeat that correction process, which is fine. It can work if you're careful about it, but if it's the further up the chain it's corrected, the more robust it is probably. So yeah, if you have that pipeline, that's good.
One more question I had is, should we always do the deployment calibration first before we digitize species sequences, or does it not matter which way we do it?
The order doesn't matter. So
okay.
All that matters is what anything that you've digitized comes out in the data export, regardless of which order you did it in.
So it doesn't matter if we just mark the sequence of animal speed and trajectory and then do the deployment calibration a lot later?
No.
Okay, great.
Yeah. And you can come back and alter a deployment calibration digitization set and re-export, and it'll take account of that change. So yeah, the calculations happen at the point of data creation at export.
Yeah. And then maybe finally, if there are other people here who are using Browning HP5s, this is something we learned from experience, is we were trying to get really good calibration on the field. And what we did was one person was clicking manually, clicking the photos while the other person was moving, so that we knew we had covered the whole field of view. But this is not a good practice, especially if you have set it up to a rapid fire. We had 3 photos in a rapid fire setting. This is not good because for some reason, these cameras change the resolution of photos. And Agouti does not like anything that's in a different resolution from everything else. So we had to go back. It was a massive amount of work for us to redo. We could change the resolution, but this is something we still struggle with. So, I mean, other people who are using the same camera, just don't click manual photos is my recommendation. I hope you don't have to redo what we had to redo.
That's yeah, thank you for the warning. I'm not quite sure I understand what you mean by manual photos.
So you can click. So Brownings, they have an LCD, so you can actually see where the person is.
Yeah.
And what we had is one person was next to the camera and manually clicking the E button, so we know it has clicked.
Oh.
So
right.
if you do the manual E button, and our intention was we want to make sure we get all the corners, all the sides.
Yeah. No,
it's a
good idea in principle. I must admit, I've not seen these models, so I didn't know that was an option, that you can actually manually press the shutter button effectively. Yeah. But those images come out at a different resolution. Yes,
at a different resolution. Yeah.
That would cause big problems.
Exactly.
Oh dear. Yeah. Sorry about that.
But hopefully someone else doesn't have to repeat it and can learn from our mistakes.
Yeah. Thank you.
Thank you. Sorry, I took a lot of time.
No, not at all.
Yes, about that, we strongly suggest to first set the camera get it going with a proper setting, close it, and then do the deployment calibration without touching it anymore before taking it off, so that you're sure the camera is not moving. And yeah, the way you were describing is certainly smart, because you're sure, as you said, that you would get all the necessary points. But probably the best way to do that is to spend a couple of more minutes, and if you have someone triggering the camera for you, then it's gonna be pretty safe to get all the points. And so this way you're sure that that the points are going to be okay, the camera has not been moved, and so on. So yeah, that's the way we recommend to do it, to be safe. So there's another question from Philippa.
Yeah. So you don't actually need to do anything, because the essentially deployments are automatically merged by location name. So long as your deployment is, well, I assume, correct me if I'm wrong, but presumably your second deployment would have been registered to the same location name as the first. In that case, the trap rate will be calculated by location name, grouped at that level. So the information will be, as you say, merged to that level, which is what you want. So that's your spatial unit of replication. Does that make sense? Okay. Yes, so I would go back and just make sure that the names are harmonized. Yeah, it won't, the GPS point, the coordinates won't help to do that merging. So yeah, I would suggest that you go back to Agouti and remove the tagged name and register the second deployment to exactly the same location. Then you should be okay. Is that okay? Massimo?
Okay. Marcus, I was wondering if the strategy to set the number of digitized sequences to optimize the precision of the estimate can be to play a little bit with the coefficient of variation. You suggested a number between 100 and 200, which can be a general suggestion, but if they, for instance, start with 100 and then they look at the coefficient of variation of the estimates of density, then maybe considering a threshold of 0.3, for instance, if they see that the coefficient of variation is still high, they can add more sequences up to 150, for instance, and then look again at how the coefficient of variation changed, and if it was reduced by this increase, then they can be satisfied. Otherwise, they can increase more, of course, if the sequences for that species are available.
Yeah, I think that's a good idea. Just to say that you can also look at the relative coefficients of variation in your estimates table and see whether there's any potential for reducing coefficient of variation significantly with more digitization. So me just show you what I mean. So you have your, can you see my spreadsheet?
Yes,
yeah.
Yes.
So you've got your estimates and you've got your coefficients of variation here. So you've got your, so you've got pretty high because we had these tiny sample sizes. Let's say speed was also 0.321 or something. I'm just making this up. And then let's say our density was 0. something.
Yeah.
So the way that, oh yeah, that's with that, those sort of numbers that, yeah, I'm guessing that the this density coefficient of variation is going to be about 80% or more, something like that. And that's because these coefficients of variation are all quite high. So this is 0.5 for trap rate, getting on for 0.3, 0.3, 0.4, 0.3. So these all add up in a way that basically the coefficients of variation, the squared coefficient, overall coefficient of variation is the sum of the squared coefficient variations of the component models. So if these are all in a similar range, then that's all going to add up. So the difference between the trap rate and coefficient of variation and the density coefficient of variation is quite large. That suggests that the other component parts, other coefficients of variation for the component parts are adding quite a lot. So that suggests that there is still good scope for reducing the coefficient of variation further by perhaps adding some more digitizations. If, on the other hand, you've got a trap rate coefficient of variation of 0.5, and these are already quite low, so 0.1, 0.05. Let's ignore those. Let's say the overall speed is 0.08 or something. That probably is going to give you a density coefficient of variation very close to the trap rate. So that suggests that the overwhelming contribution of variance in density is from the trap rate component, and digitizing more individuals isn't going to help with that. So that suggests, you've probably saturated on enough observations there to get the coefficient of variation as low as you're going to go, and any remaining imprecision is just down to the fact that you've got high variance in your trap rate. Actually, spatial analysis, in theory, might help with that if you can attribute some of that variance to variation in habitat, but that's again where we need these new tools that are hopefully coming through soon. But for the moment, we just have to live with that variance in the overall estimate. Does that make sense?
Okay. So to summarize, if we notice that the coefficient of coefficient of variation of the density is high, and in parallel, the coefficient of variation of the overall speed or the other estimates apart from trap rate is also high, the suggestion can be to increase the number of digitization.
Right.
If not, then probably this will not help, and it's a matter of counter rate and variation, and so there is no solution.
Exactly.
Okay. Thank you very much.
All right.
Please, Delia.
Mm-hmm.
Hi there. I have a question regarding the number of deployments in which we can fail, because of course a number of cameras will fail for various reasons. because they didn't work or because they were moved by animals and damaged. So what is the margin that the model can tolerate? Or is that something that we're going to just get in our studio the moment we run the model? We're going to get an error that says we cannot run it because there's not enough data.
There's no threshold that tools for automatically telling you that you're not going to be getting a reliable estimate. So the example that I showed you was run on terrible data with not many deployments and very few observations, and it still gave me an answer. So there is, because there are no hard cutoffs, I can't give you a, say 29 deployments is not enough, but 30 is okay. It's you have to make a judgment. The user has to make a judgment on that. And there are guidelines, rules of thumb, which you've been given, I think. And obviously camera failure comes into that. So, we can normally expect some percentage, maybe 5% for that to happen. So it's worth building that into your survey design and making sure that you have enough over and above the guideline to allow for some of that wastage. Yeah, so in the end, I think so long as you built in that kind of buffer into your survey design, you should be okay.
Right. Thank you.
Mm-hmm.
Are there any other questions? Right. So, at this point, I would like to, well, first of all, thank Marcus for the presentation and all the time and details. I think it was, as usual, super useful and clear. And thank Jim as well, even though I think he had to leave. And yeah, also thank you all for participating. You will receive the link with the recording of this training for you to have it and being able to watch it again in case you have doubts about certain parts, or to share it with your collaborators if you have someone else joining your team and you want them to have a look at it as well. Also, I would like to take the chance to remind, this is for all the, let's say, old collaborators, that if they have not done so yet, they would be required to also run the analysis again for the previous years, because as you probably know, last year we proposed the new results format, the one that Marcus just described, with a CSV results table that is produced at the very end of the analysis process. And this is extremely useful for us in order to build a standardized and neatly organized database. So if you haven't done the analysis with this new procedure for your previous results, they are not currently included in the new database. So that is fundamental for us to include them, and also for you to not have them, let's say, not discarded, but not included in the new database and all that is going to be done with it from now onwards. So about this, we also are going to share instructions on how to share your CSV results. That's going to be extremely easy and straightforward. Same as last year, that's going to be done through an online questionnaire where you can specify some details about your study site and where you can attach your results CSV. So yeah, I think this is kind of it. So if there's no question and no one wants to add anything, I would like to thank everyone once again, and we can say goodbye, and we'll be in touch with all of you for the further steps. Great. So thank you, and bye everyone. Thanks, Marcus, once again.